Welcome to Deep Dive Quiz for Lesson 23. Now, Lesson 23 was to assess and mitigate the vulnerabilities of security architecture, designs, and solution elements. And it was a big lesson. We talked about client-based, server-based, and distributed systems, database management systems, operational technology, or OT, cloud-based systems, the Internet of Things, IoT, and the Industrial Internet of Things, IIoT, virtualization, and automation, and solution elements. So now together, we're going to do a 10-question quiz. So make sure you have a pencil or a pen and a piece of paper. Put me on pause as often as you need to. Really want to make sure that you're taking the time to write down your answers, right? Don't make me do all the work. You have to be involved in this as well. So let's get started. The integration of disparate tools and platforms for an automated response. Is that our description of automation, orchestration, a SCADA system, or an HMI, a human-machine interface? This is the integration of disparate tools and platforms for an automated response. What do you like for an answer? Well, for sure, that is going to be orchestration. Orchestration is the integration of disparate tools and platforms for an automated response. Should we check? All right, let's see. And that is correct. Oh, we've got a matching one. Down the left-hand side, we've got Platform as a Service, PaaS, Private Cloud, Cloud Bursting, and IaaS, Infrastructure as a Service. On the right-hand side, we have Customer deploys onto the cloud infrastructure, Customer provisions bare metal resources, provision for the single organization exclusive use, and the on-demand and temporary use of the public cloud. So we want to match those cloud-related terms and descriptions. Definitely put me on pause, match them up, and come on back when you're ready. All right, cloud deploys onto the cloud infrastructure. That sounds a lot to me like PaaS, or Platform as a Service. The customer provisions bare metal resources. Well, that looks like IaaS, Infrastructure as a Service. Remember, we have Infrastructure as a Service, Platform as a Service, and the other one is Software as a Service, but not in this question. All right, the on-demand and temporary use of the public cloud. That's going to be cloud bursting. And provision for the single organization exclusive use. For sure, that's a private cloud. So let's go through these. PaaS, or Platform as a Service, the customer deploys onto the cloud infrastructure. A private cloud, which is provision for the single organization exclusive use. Cloud bursting, the on-demand and temporary use of the public cloud. And IaaS, or Infrastructure as a Service, the customer provisions bare metal resources. Do you agree? Well, let's check it out. And that is correct. All right, the term that describes the use of IT solutions that are managed outside of and without the knowledge of the IT department. Now, we've talked about this one a couple of times. Is this CASB, Security as a Service, Shadow IT, or outsourcing? Think about this for a sec. It's a term that describes the use of the IT solution that are managed outside of and without the knowledge of the IT department. Which one is it going to be? I'm going to choose Shadow IT. Shadow IT is that term that we use when we're using an IT solution, maybe software as a service, something right from the cloud, right, that are managed outside of and without the knowledge of the IT department. No, so if you answered CASB, you were kind of close, right? CASB actually is what we use to mitigate the risks of Shadow IT. Remember, CASB is a device, an appliance or software that is between the user and the cloud and can proxy the access to the cloud and interject the security policies as needed. But the answer we were looking for here was Shadow IT. Let's double check, and that is correct. Oh, we got a drag and drop. Okay, let's read it together. We'll look at the words on the bottom. Then you're definitely going to want to put me on pause while you take a moment to fill in the blanks. Blank is the foundation of an IoT device. Blank, detect and respond to changes in the environment. Blank, translate electrical signals into physical action. Blank are used to send and receive RF, that's radio frequency, signals. And blank is how IoT devices communicate with each other. So what do you have for options? VNC, SoC, embedded system, sensors, actuators, smart connectivity, RTOS, and transceivers. So put me on pause, fill in those blanks, come on back when you're ready. Okay, so what's the foundation of an IoT device? Well, that's going to be an embedded system. Right? An embedded system is the foundation of an Internet of Things device. Right? Blanks detect and respond to changes in the environment. Well, that is going to be our sensors. Right? Sensors detect and respond to changes in the environment. So what is it that translates electrical signals into physical action? That's going to be an actuator. Actuators translate electrical signals into physical actions. So now we've got blank are used to send and receive RF signals. Sounds like a transceiver to me. Transceivers are used to send and receive RF signals. And lastly, blank is how IoT devices communicate with each other. And that's going to be smart connectivity. So reading the whole paragraph, embedded systems is the foundation of an IoT device. Sensors detect and respond to changes in the environment. Actuators translate electrical signals into physical action. Transceivers are used to send and receive RF signals, and smart connectivity is how IoT devices communicate with each other. Agree? Let's check. And that is correct. Oh, another matching one. This time we're going to match the following properties of virtual machines with their descriptions. Down the left-hand side, we have containers, a Type 1 hypervisor, a Type 2 hypervisor, and persistent. Down the right-hand side, we have a lightweight environment, requires a host operating system, saved for future use, and direct access to the hardware. So put me on pause, match them up, come on back when you're ready. Okay, lightweight environment. Wow, that's right up there, right next to it. That's going to be a container. Requires a host operating system. Our options are Type 1 hypervisor, Type 2 hypervisor, or persistent. Well, requires a host operating system is going to be a Type 2 hypervisor. Because what's a Type 1 hypervisor? Well, a Type 1 hypervisor has direct access to hardware. And when we talk about persistence, in this case persistent VDI, well, it is saved for future use. So our match here would be containers or lightweight environments. Type 1 hypervisors have direct access to hardware. Type 2 hypervisors require a host operating system. And persistence means it's saved for future use. You like it? You agree? Let's check. And that is correct. All right, let's move on to number 6. This situation occurs when the number of virtual machines is out of control. Is this virtualization sprawl, network virtualization, virtual machine escape, or overallocation? I don't think you should even have to put me on pause for this one. You know this answer. What is it? Well, when the number of virtual machines is out of control, we refer to that as virtualization sprawl. Now, the other big concern we have with virtualization is virtual machine escape. And that's when the VMs and the host device can communicate, and that should never happen. But the situation that occurs when we've got too many virtual machines out of control, we're not managing them well, that's going to be virtualization sprawl. We're going to check it, but I'm pretty sure that's correct. All right, number 7. The ability to fit the resources needed to cope with loads dynamically by provisioning and deprovisioning resources, adding resources, taking resources away. Is this scalability, pay-per-use, serverless, or elasticity? Remember, I gave you the example of the rubber band between your thumb and your finger. You can stretch it out, bring it back, stretch it out, and bring it back. Another name for that rubber band is? You got it. Yeah, this is going to be elasticity. Now, don't confuse elasticity with scalability. When we talk about scalability, we're talking about to grow. We either talk about scaling up or scaling out, where elasticity is the ability to fit the resources needed to cope with loads dynamically by provisioning and deprovisioning resources. And, of course, that one's correct. All right, number 8. Which statement does not describe high-performance computing? Again, really focus in on does not. Right? So that means that 3 of these do and 1 does not. But if you read these too quickly and read which statement does describe high-performance computing and you chose the first answer you came to, you'd probably be wrong. So which statement does not describe high-performance computing? Can perform complex calculations. The best-known HPC is a supercomputer. Each computer in the cluster is referred to as a node. Data handling operations are deployed as close to the source as possible. 3 of those describe HPC or high-performance computing, 1 does not. Put me on pause if you want to read through those again. Well, let's go through these. Can perform complex calculations? Absolutely. That describes high-performance computing. Best known HPC is a supercomputer? You bet. Each computer in the cluster is referred to as a node? Absolutely. Data handling operations are deployed as close to the source as possible. That doesn't describe HPC. What does that describe? That describes edge computing. So that's the one that does not describe high-performance computing. Agree? We'll check. There you go. Number 9, one more matching. We're going to match the following solution elements with their descriptions. On the left-hand side, we have containerization, infrastructure as code, microservices, and serverless computing. On the right-hand side, we have technology that allows applications to run in isolated environments, dynamic allocation of execution resources, independent deployable components, or using code to automate provisioning. Put me on pause, match them up, come on back when you're ready. Right. Technology that allows applications to run in isolated environments, that's going to be containerization. Dynamic allocation of execution resources. Sounds a lot like serverless computing to me. Using code to automate the provisioning? Yeah, right there. Infrastructure as code. And lastly, independent deployable components. That's going to be microservices. So reading through these, containerization, technology that allows applications to run in isolated environments, infrastructure as code is using code to automate provisioning, microservices are independent deployable components, and serverless computing is a dynamic allocation of execution resources. Let's check and see if we're right. And we are. All right, let's do our last question together here. And this is another drag and drop the words to complete the sentences. So we'll read the whole thing. We'll read the words that are available to us. Then you'll put me on pause. You'll fill in the blanks, and then we'll do it together. Blank combines data from multiple sources. Blank is the process of analyzing data for trends. Blank is data about data. Blank is when individual pieces of data are combined to create a bigger picture. And blank is the ability to derive information that's not explicitly available. And our options here are metadata, data warehousing, inference, aggregation, data mining, and transference. So put me on pause, fill in the blanks. You don't have to start right at the top. If you got a question like this, you could start anywhere and start using up your words. Come on back when you're ready. All right, blank combines data from multiple sources. That's going to be data warehousing. Blank is the process of analyzing data for trends. Sounds a lot like data mining to me. Blank is data about data. Well, metadata is data about data. Blank is when individual pieces of data are combined to create a bigger picture. So when we put them all together, what are we doing? Well, we're aggregating. So it's going to be aggregation is when individual pieces of data are combined to create a bigger picture. And lastly, blank is the ability to derive information that's not explicitly available, and that's inference. So reading through the whole paragraph, data warehousing combines data from multiple sources. Data mining is the process of analyzing data for trends. Metadata is data about data. Aggregation is when individual pieces of data are combined to create a bigger picture. And lastly, inference is the ability to derive information that is not explicitly available. Let's check our work. And we are correct. Awesome, we did it again, 100%. All right, we've got a lot more to do, quite a bit more in this module, so let's continue on. I'll see you at the next lesson.